Hello everyone, we're now doing example 9, which is on solving logarithms through changing exponential bases. So, basically, we're going to be solving for what the value of each of these logs are, which we've done this over and over and over. Okay, but this time, it's a little bit harder to get the same base on both sides of your equation. Okay, so I'm going to show you when it's not as easy to get the same base, how you can still get the same base on both sides. Okay, so looking here, remember when we solve our nifty logarithm equations, we go ahead and set it equal to whatever you want, which, I don't know, I'm just going to pick x. Okay, so I'm going to pick x. Okay, and when we solve a log, I'm going to convert this thing into an exponential. So, the base of the exponential is the base of the log, which is 9. Alright, and then remember, these two are going to trade places. Okay, so, my 27 is going to hop to the other side of the equal sign, and my x is going to become the exponent of my 9. So, x is going to hop up here. Okay, and my 27 is going to hop to the other side. Okay, and then remember you can also use the other technique where you do like the little roundabout method. Okay, so you could say 9 to the x power equals 27. Okay, so whatever makes sense in your head, that's what you need to do. Alrighty, so typically when we solve these, one of our bases was already given to us, and that was the base that we would use on the other side. Okay, but so we're trying to think of a base that not only goes into 9 and 27, but I could also raise to a power and get 9 and 27. Okay, which I can't use 9 because 9, for example, 9 squared is 81. That's already way higher than 27. So 9 is off the table. So I have to think of another base that not only goes into both 9 and 27, but I can raise to an exponent and get 9 and 27. So the only other thing that goes into 9 and 27 that's alike is 3. So I'm going to be converting each of these bases to base 3. So let's see what happens with that. Okay, so let's see. Alright, so my 9, we're going to convert to base 3. Okay, which I'm going to leave my x outside my parenthesis, and we'll deal with that in just a moment. So I need to think about 3 to what power will give me 9? Well, let's think. 3 times 3 is 9, so it's 2. So my new exponent is 3 squared. Okay, and now on my other side, we need to think about 3 to what power will give me 27. So let's see here. 3 times 3 is 9, times 3 is 27. So it's going to be 3 to the third power. Alright, so now if you notice, we do have the same base on both sides. Look at that. Okay, now, before we drop our exponents down, then we must combine these lovely exponents right there. Okay, which whenever you have an exponent right beside an exponent, the way you combine them is through multiplication. Okay, so this is going to be 3, and then 2 times x is 2x equals 3 to the third. So now that my exponents are combined, I can drop my exponents because we have the same base on both sides. Yay! So I'm going to drop down my exponents. Okay, what we're left with is 2x equals 3. Okay, which we need to solve for x. Okay, so to get x by itself, what I need to do, 2 is secretly multiplying to my x, so the way we move it to the other side is by dividing both sides by 2. Okay, so my final answer would be 3/2. Exciting. Fractions are awesome, you guys. They're our friends. Okay, so that would be our very first answer. So all that up here just secretly equals 3/2. Alrighty, now part B is pretty much the same as part A. So if you feel like you got part A, go ahead and pause this video and fast forward to the end and see if you can figure out how to do part B. Okay, so same thing. We start by setting this bad boy equal to something, which I'll just pick x to make our lives easier. Alright, and then I need to convert this into an exponential. So, the base of my log becomes the base of my exponential, which the base is the 4. Okay, 4, and then remember, these two are going to swap places. Okay, so my x is going to hop to the exponent of my 4. And the 32 is going to hop to the other side of my equal sign. Or again, if you like the roundabout way, 4 raised to the power of x equals 32. Either way. All right, so we have to figure out a base that not only goes into 4 and 32, but I can also raise to a power and get each of those. So let's see if 4 works. This 4 goes into 32. Okay, so let's see here. 4 times 4 is 16, and 16 times 4 is 64. Okay, so unfortunately, I can't raise 4 to a power and get 32. So I'm going to have to think of a different number that goes into 4 and 32, and something that will work out when I raise it to a power to get 4 and 32. So the only other thing that goes into 4 and 32, you guys guessed it, it's 2. You already knew. You guys are super smart. So I'm going to rewrite each of my bases using a power of 2. Okay, which like last time, I'm going to put my x outside the parenthesis, because we'll deal with it in a moment. Okay, so let's see here. 2 to what power gives me 4? Let's see. 2 times 2 is 4. So my exponent would be 2. All right, and then on this side, we have to figure out which exponent, when I raise it to a power, will give me 32. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Okay, so my next exponent is 5th. 2 to the 5th power will give me 32. All right, guys, now before we can drop down our exponents like we did over here, remember we got to combine our exponents, which whenever you have an exponent right next to an exponent, the way you combine them is by multiplying. Okay, so 2 times x gives me 2x as my exponent. And this will equal 2 to the 5th. So now my bases are the same. Yay! I have a 2 on both sides. So that means I can drop my exponents down and set those bad boys equal to each other. Nifty. Okay, and last step, you guys, we got to get x on one side by itself. So 2 is secretly multiplying to the x. So the way we bring it over is through division. Okay, which the 2 divided by 2 will cancel out and leave me with a 1. And what we're left with is x equals 5 halves. All right, so all of that is just secretly 5 halves. Pretty nifty, right? Awesome job, you guys.